Okay, so this is the second video for the ambiguous case with the law of sines. In the first video, we went through and looked at the 6 possible scenarios, and as promised, in the second video, we're actually going to go through and solve some triangles and see how we apply all this stuff, okay? And I will be referring back to all of these things that we derived here. I'll be going back through and we'll be referring back to this table. If you haven't watched that first video, you really need to, so you have an idea of what exactly is going on. Okay, so first one. I have this triangle, and notice I'm given an angle and 2 sides. Now, I'm assuming here, because of our naming conventions that we went through in previous work, that side C should be opposite angle C. And then side B will be adjacent to this given side then, okay? So I don't know if this is going to make a triangle, so when I draw these, I usually like to make them first off not as a triangle. I'm going to set them up looking like this, not as a completed triangle. I've got a ray here at the bottom going off to the right, and then I've got my angle, and this time it's C, which is 96 degrees. My adjacent side B, which is 17, and then my opposite side C, which is then 19. Okay, now if this does make a triangle, angle B will be down here, okay, and it would have to continue down like that. That would be down here across from side B. Okay, it'd have to be across from side B. And then the one that is left, we'd have angle A up at the top and side A down at the bottom, if this actually makes a triangle. Now let's find out. First off, I notice that the angle that I'm given right here is obtuse. Oh, okay, that's interesting. Obtuse. So I'm going to go back here and look at my table and look at my obtuse angles, which is over on the left. Okay, so we're dealing with this stuff over here on the left. Now, when that is the case, I've got 2 possible situations. Both of those situations compare the opposite side length to the adjacent side length. If the opposite side is less than or equal to the adjacent side, I have no triangles. If the opposite side is greater than the adjacent side, then I have 1 triangle. So let's go ahead and look here. I've got this situation where my opposite side is bigger than my adjacent side. Okay, so right away I notice that C is greater than B, the adjacent side. So that means I'm going to have 1 triangle. Okay, so let's go ahead and solve my triangle. I'm going to use all my regular old law of sines stuff. Okay, so first thing I identify is what my angle side pair is. And this is my angle side pair right here, side C with angle C. So I will set this up as the sine of 96 over 19. Sine of 96 over 19 is equal to, and in this case, this is kind of cool, we're going to be looking for an angle, which we didn't do in earlier work, so let's do that. We're going to be looking for angle B, so I'm going to say the sine of angle B over 17. All right, now we're going to go ahead and cross multiply. 17 times the sine of 96 is equal to 19 times the sine of B, and then divide by 19. All right, and that's going to tell me what the sine of B is equal to. Okay, sine of B. What is that going to be equal to? All right, so I'm going to go over to my calculator. Now I'm dealing with degrees, so I need to make sure my mode is in degrees. Right now it's in radians. So I'm going to move over to degrees. All right, cool. And I'm going to do 17 times the sine of 96, close my parentheses, divided by 19, and that comes out to 0.8898. I'm going to go kind of far with this, 0.8898. Now I still need to find out what angle B is, so I'm going to take the arc sine, or the inverse sine, of both sides. Okay, inverse sine on the right, that cancels out, and left with angle B is equal to, all right, so I'm going to go second sine for my inverse sine. Now here's a nice little trick so I don't have to put in a whole bunch of decimal places. I'm going to go second and my negative key if you're using a TI calculator, and it refers back to my answer, my previous line, and it's going to take the inverse sine of that, and I get 62.85 degrees. 62.85 degrees for angle B. Excellent. So there's angle B, 62.85. Now I've got to go for side A and angle A. Now, next move I'm going to do is to find the measure of angle A. And I'm going to use the fact that all the angles add up to 180. So the measure of angle A is going to be 180 minus 96 minus my 62.85. Okay? So what does that come out to be? Let's see. 180 minus 96 minus 62.85. 21.15. 21.15. That's going to be the measure of angle A. All right, cool. So we found that next piece. Now let's find the last piece, which is side A. All right, cool. So the measure of side A, I'm going to do, once again, going back to my original angle side pair with C. So I'm going to say the sine of 96 over 19 is equal to, now in this case I'm going with A, so the sine of 21.15, sine 21.15 over whatever A is. Alright, let's cross multiply, so I get A times the sine of 96 is equal to 19 times the sine of 21.15. Divide by the sine of 96. And let's find out what A is. Okay, so we have 19 times the sine of 21.15, close parentheses, divided by the sine of 96, close parentheses, and we get 6.89. 6.89 for my answer. There we go. We found all our missing parts. We found angle B, we found angle A, and we found side A. All right, all after we determined that there was a triangle to solve for. If this had come out to no triangle, then we'd be done. There'd be nothing to solve. All right, so, but here we did have a case. Now in the next example, we're going to take a look at a situation that might have 0, 1, or 2 possible triangles to solve for. Okay, so please take a look at the next video and we will go over that. So this was the Law of Sines video 2, the ambiguous case video 2, sorry. Now we'll have the Law of Sines ambiguous case video 3 coming up next.